To our professor, Dr. Wendy Salomo, and to my Sci 205 classmates, good day. I am Isabel Alparo, a MAED Sci student, and I will be presenting the updates on periodic properties of elements. So I will be providing you with the overview of the topic, some fun facts about the elements in the periodic table, recent researches found in journal articles, and innovations. As we, science teachers, all know, the elements in the periodic table are arranged in order of increasing atomic number, with hydrogen as the lightest element with an atomic number 1, and uranium as the heaviest naturally occurring element with an atomic number of 92. All of these elements display several other trends, and we can use the periodic law and table formation to predict their chemical, physical, and atomic properties. So what is stated in the periodic law? Periodic law states that the physical and chemical properties of the elements are periodic functions of their atomic numbers. So it means that when elements are arranged in order of increasing atomic number, there is the periodic repetition of their chemical and physical properties. So the regular variation of the properties of elements with increasing atomic number is what we call as periodic trend. So a trend is just a pattern. So if we look in the periodic table from top to bottom within a group, we might see a pattern for a certain property. And if we look left to right within a period of the periodic table, we might also see a trend in a certain property. So the periodic properties of elements are ionization energy, metallic character, atomic radii, electronegativity, ionic radius, electron affinity, chemical reactivity, and shielding effect. So let's start with what is atomic radius. Atomic radius is the radius or size of the atom. Looking at the largest of all the elements on the periodic table, what we see is the top to bottom trend of the atomic radius increasing, but as you go from left to right within a period, the atomic radius actually decreases. So the smallest radius is helium, while the largest radius is cesium or francium. Next, ionization energy. It is the amount of energy needed to remove an electron from an atom. So here's the overall idea. The smaller the atom is, the harder it is to remove an electron from it. So ionization energy decrease from top to bottom, and ionization energy increase from left to right of the periodic table. Next is electronegativity. Electronegativity is the measure of an atom's attraction to electrons. So looking at the electronegativity values from left to right, I'm gonna say that electronegativity increases. If we go top to bottom in a group, the electronegativity actually decreases. So fluorine is the most electronegative element with an electronegativity of 3.98, and the least electronegative is francium. So aside from it being the least electronegative element, francium is the most expensive element on the periodic table, because to produce 100 grams of francium, it would cost a few billion US. So next is metallic property. Metallic property is the propensity to behave like the elements that are classified as metals in the periodic table. So metallic property decrease from left to right within a period, and metallic property increase from top to bottom within a group. So the most metallic is francium, and one of the least metallic element is, of course, a nonmetal, which is helium. Helium is the first element to be identified outside the Earth. Number 1 is oxygen. So do you know that oxygen is the main player in aurora borealis? So in aurora, colors we see is depending on the type of atom that is excited. At higher altitude, due to low concentration of oxygen atoms, red color is visible. At lower altitudes, due to higher concentration of oxygen, green aurora is predominant. Okay, next is chemical reactivity. Chemical reactivity is the impetus for which a chemical substance undergoes chemical reaction. So reactivity decreases as you go from left to right across a period, and reactivity increases as you go down a group. Next is electron affinity. Electron affinity is the amount of energy released when an electron is attached to a neutral atom or molecule in gaseous state to form a negative ion. So electron affinity increases from left to right within a period, and electron affinity decreases from top to bottom within a group. Chlorine has the highest electron affinity while mercury has the lowest. Next is ionic radius. Ionic radius gauges the size of an electrically charged atom. So ionic radius increases as you move from top to bottom on the periodic table, and ionic radius decreases as you move across the periodic table from left to right. So shielding effect, it is where electrons in an atom can shield each other from the pull of the nucleus. So across period, shielding remains constant and shielding increases down a group. So here's a summary of the periodic trends or periodic properties of elements. Here is a super trick to memorize periodic trends so that it would be easier for you to recall the trends and not to be confused with it. So here are the recent researches found in journal articles. So the Pauling scale is the first and the most common electronegativity scale present in every chemistry textbook. It later transpired that the predictions made with Pauling scale had a rather low accuracy. So the Skoltech professors Artem R. Oganov modified Pauling's formula and ended up creating a new scale of electronegativities. So with the new formula, they determined the electronegativities of all the elements that works both for small and large differences in electronegativity. Oganesson is a chemical element with a symbol Og and an atomic number 118, which is the most recent addition to group 18, which is the group of noble gases. Noble gases, as we know, are electrical insulators. So calculating the band structure of this noble gas, the band gap of Og completely breaks in with the trends. So when we talk about band gap, it's the minimum energy that is required to excite an electron up to a state in conduction. So the small band gap of Og means that, in contrast to all other noble gas solids, the solid form of Og is a semiconductor. Periodic table. Scientists propose new way of ordering the elements. So two scientists in Moscow, Russia had this proposal for a new order. Their approach, building on the earlier works of others, is to assign to each element what is called the Mendeleev number. Each area of the new table had been color-coded to indicate its vulnerability. Elements are not lost, but as we use them, they become dissipated and much less easy to recover. Red indicates that dissipation will make the elements much less readily available in 100 years or less. As you can see, 31 carry a smartphone symbol, reflecting the fact that they are all contained in these devices. With this, we must do all we can to conserve and recycle these elements, because many of the objects and technologies that we now take for granted may disappear or may be available only to richer people. An extended periodic table theorizes about chemical elements beyond those currently known in the periodic table and proven up to Oganesson, which complete the 7th period in the periodic table at an atomic number 118. Elements 119 onwards are named but still undiscovered. Effort of ionic radius on dope style of silver and copper or zinc oxide nanorods for photodegradation of methylene blue. The homogeneous copper zinc oxide and heterogeneous silver zinc oxide nanorods were synthesized by controlling the ionic radius of copper and silver with lattice of zinc oxide. The study of the photoelectric properties suggested both the homogeneously and heterogeneously doped zinc oxide displayed an increased photocatalytic performance. The present work could provide a further insight for the design of zinc oxide-based nanomaterials and development of their applications in environmental catalysis. These findings are important for water purification applications, such as photodegradation of pollutants into simpler and non-toxic components. Using photocatalytic materials is a very promising and widely researched technique for wastewater treatment. Antimicrobial properties of copper and the orbital capture. The purpose of this note is to stimulate interest in measuring and characterizing the emitted ultraviolet frequencies in antimicrobial copper materials. The antimicrobial sanitizing materials are urgently needed to limit the spread of COVID-19 virus. In the current pandemic, ultraviolet radiation is often used for sterilization. It is shown that 3D orbital capture in copper can result in radiation generated by copper materials. The fact that copper has antimicrobial properties and that ultraviolet radiation is very effective for COVID-19, sanitizing strongly suggests that copper produces radiation in ultraviolet region. Interactive cube for effective demonstration of virtual periodic table. In this paper, they presented a cube-based interface in virtual periodic table or CIVPT for demonstration of the detailed information of chemical elements. The cube, with its 6 faces, provides the information of chemical elements, chemical properties, physical properties, electronic configuration, usage of an element in daily life, and chemical bonding respectively. Outcomes of the evaluations revealed that CIVPT enhances students' learning and their motivations in gaining knowledge about chemical elements. Superheroes, foods and apps bring a modern twist to periodic table. Researchers introduce an innovative way to make learning about elements much more approachable by using pseudo-periodic tables filled with superheroes, foods, and apps. The pseudo-periodic versions replaced elements with single items to demonstrate one or more concepts needed to understand the trends and layout of the real chemical one. In the table, it features different sizes of fruits to make it easier for the students to understand atomic size. The researchers say that the familiar items reduce stress and help students successfully build their base of chemistry knowledge. A digital periodic table that instructors can use in the classroom to highlight elements and illustrate periodic trends. This paper describes a responsive digital periodic table that has been specifically designed as a visual aid for high school or college chemistry classrooms and lecture halls. The periodic table runs in a web browser and can be used in any classroom that has a digital projector and screen. It features click to highlight table cells that an instructor can use to draw students' attention to specific elements and style schemes that can be used to color groups of elements and illustrate periodic trends. Its size can be adjusted to fit the screen in the classroom in which it can be used. So that's all for my presentation for today.